Hey there guys. In this next lesson we're going to be reviewing what you learned in 6th grade about solving 1 and 2-step equations. So solving equations, another term for that is called finding the solution or solutions of an equation. And to do that we use inverse operations to undo the operations within the equation. Your goal for solving all equations, whether it be a 1-step, a 2-step, or a 6-step equation, is to isolate the variable. Okay, that means get the variable all by itself on one side of the equal sign. And so to use your inverse operations properly, you need to know what the inverse operations are. The inverse of addition is subtraction. Therefore, the inverse of subtraction is addition. The inverse of multiplication is division. And of course, the inverse of division is multiplication. You also need to remember that equations are like balances. If you've ever used the pan balances in science class, you know that in order to get a balance to balance, you have to have the same weight on one side as you do on the other. So equations are like that. Okay, the equal sign's like the middle part. So whatever you do to the left side of the equation, you must also do to the right side and vice versa. So that's what we're going to practice here in these first few examples. These are all 1-step equations, and again, this should be a review from what you did in 6th grade, but we still need to take a look at this in order to be successful in the more complex equations that you'll see later on. So number 1, I have m plus 12 equals 10. So my variable is here. Anything on my variable is on the left side of the equation. Anything else on the left side that is not the variable, I want to undo so that I can isolate the variable. So I see an m plus 12 here. This is addition, so I need to undo addition with subtraction, and so I'm going to subtract 12 from both sides. So once from the left and once from the right. Notice again how I'm lining up my plus 12 and my minus 12 here directly on top of each other so that I can see that they cancel, and all that's left on this side now is the m. M equals 10 minus 12 is negative 2. So your solution to this equation is negative 2. You will sometimes see solutions to equations written inside braces. Okay, those are those squiggly lines there. So if you see that on an answer key somewhere, just know that that just means the solution of the equation is negative 2. Okay, for number 2, I have negative 2 equals g minus 9. This time the variable's on the right side of the equation, so I need to get rid of anything else on the right side, and that would be a subtract 9. So I'm going to undo subtraction with addition, add 9 to the right side, and then add 9 to the left side to keep the equation balanced. The negative 9 and positive 9 here will cancel, so on the right side I'm just left with g equals. Notice also how I'm lining up my equal signs. Okay, that's going to be really important in order to keep organized work, is to make sure you line up your equal signs. Negative 2 plus 9 is positive 7. So your solution to this equation is g equals 7. Number 3, we have negative 7y equals negative 91. Negative 7y means negative 7 times y, so I'm going to undo the multiplication with division. When we show division when solving equations, you must include a fraction bar. Don't put this symbol right here. It looks too much like a plus sign. Okay, I want you to use the fraction bar when showing division. So we're dividing by negative 7 on the left and on the right side. When I divide on the left, it cancels out my negative 7, so I just get my y equals negative 91 divided by negative 7 is a positive 13. So your solution to this equation is 13. For number 4, we have a over 9 equals negative 4. That fraction bar there means division, so that means I need to use multiplication to undo the division. So I need to multiply the left side by 9, which is the same thing as multiplying by 9 over 1. When I do that, the 9 over 1 will cancel out the 9 in my denominator, and so I'm just going to be left with a on the left side. On the right side, I must also multiply by 9. Negative 4 times 9 is negative 36. Okay, moving on to equations with fractions. So if the coefficient, and remember the coefficient is the number in front of the variable, the number being multiplied by the variable. So if you have an equation like that where the coefficient is a fraction, we get rid of it by multiplying by the reciprocal of the fraction. So let me show you what I mean here in example 5. Here we have 2/3 times x equals 10. Now, normally with the multiplication equation, to get rid of multiplication, we would do division, yes? In this case, we would have to divide by the fraction 2/3 because that's what x is being multiplied by. Well, you know, hopefully from 6th grade, that when we divide by fractions, that's the same as multiplying by their reciprocals. So really, dividing by 2/3 would be the same as multiplying by 3/2. So when solving equations that have fractions as reciprocals, it's just easier to jump right away to that multiplication and multiply this left side by 3/2. Doing that's going to cancel out my 3's on the diagonal and my 2's, so I'm just going to be left with x on the left side. I need to do the same thing to the right side, multiply by 3/2. So this is 10 over 1 times 3 over 2. My 10 and 2 are going to cancel to 1 and 5, so I'm just left with 5 times 3 all over 1, which is 15. So my solution to this equation is 15. Same thing for number 6. I have 4/9 w equals -8. I'm going to multiply the left side by the reciprocal of 4/9, which is 9/4. That's going to give me just w on the left side. On the right side, I'm also going to multiply by 9/4. So I have -8 over 1 times 9 over 4. My 4 and my -8 cancel to 1 and -2. So I have -2 times 9 all over 1, which is -18. Number 7, -6/5 k equals 12. I'm going to do the same thing as I did in 5 and 6, but keep in mind that we have a negative on the left side, so I need to multiply by -5/6 in order to undo not only the 6/5, but the negative sign as well. Remember, a negative times a negative is a positive, so I'm just going to get k on the left side. On the right side, I'm also multiplying by -5/6. So this is 12 over 1 times -5/6. My 6 and 12 cancel to 1 and 2. I'm left with 2 times -5 all over 1, which is -10. And number 8, -1/2 m equals -9. The reciprocal of -1/2 is -2, or -2 over 1. So that's what I'll multiply by on the left side. That's going to give me just my m, and then I will multiply by the same thing on the right side, -2. -9 times -2 is just +18. So I get a whole number answer. I have no fractions on the right side in my multiplication. It's just +18. So that's one-step equations. Now we're going to look at two-step equations here on the back side. To solve a two-step equation, we undo addition or subtraction first, and that removes the constant term, okay, the term without the variable, and then after the addition or subtraction step, we undo the multiplication and division to remove the coefficient. Okay, so that's what we're going to practice with two-step equations. Undo addition, subtraction first, then multiplication, division. There is an exception to this process, and we're going to see that at the end of the notes, but for most of your examples, this will be the order that we undo the operations in. So number 9, we have 6x plus 8 equals 50. So I'm going to start out by undoing my addition on the left side. I need to undo addition with subtraction, so I'm going to subtract 8 once from the left and once from the right side. On the left side, I'm left with just the 6x, so I have 6x equals 50 minus 8, which is 42. So that's my first step. My second step is to divide both sides by 6, because I have a 6 times x. So I do that, my 6's will cancel, and I'm left with x equals +7. 42 divided by 6 is +7. It's really important with two-step equations that we check our solutions. So I'm going to go back and show you how we go through and check a solution for an equation. We did this last year in 6th grade as well. We take the value that we get for the variable, in this case 7, and we're going to substitute that in for the variable in the original equation. So we have 6 times 7 is what we believe x to be, plus 8 equals 50. If I do order of operations now on this side, I get 42 plus 8 equals 50. And 42 plus 8 is 50, so that checks out. When you're doing your assignment, I want you to show your checks for any two-step equations, okay? Any two-step equations, you need to show this step here that the solution checks out. For number 10, I have 2x minus 5 is equal to 11. So my first step is going to be to undo the subtraction, so I'll add 5 to both sides. When I do that, I get 2x equals 16. My next step is going to be to use division to get rid of my times 2 here. So I'll divide both sides by 2, and I get x equals 8. Again, I need to check my answer. So I'm going to go back over here and make sure that 8 is in fact a solution of this equation. So we have 2 times our variable minus 5 equals 11. We believe x is 8. 2 times 8 is 16. Subtract 5 is positive 11. Okay, what we're going to do right now is I'm going to have you pause the video for 11 and 12. Pause the video. I want you to try both of these examples on your own. And then once you believe you have solutions, check your answers and then click play to make sure you're correct. Okay, so let's take a look at the solutions you got for 11 and 12. So number 11, you needed to subtract 9 from both sides first. That gives you 4 equals negative 4x. And then the coefficient is negative 4, so you have to remember to divide by a negative 4 on both the right side and the left side. Okay, so if you didn't divide by negative 4, make sure you correct that here. 4 divided by negative 4 is negative 1, so we get a solution of x equals negative 1. When I substitute negative 1 into my original equation for x, here's my work done here, I see that that checks out. Negative 4 times negative 1 is positive 4, plus 9 is 13. 12, you need to be careful for your first step on this one. We see 7 minus 3x, so you might think your first step needs to be addition because you see this subtraction sign here, but look at the order. Okay, we always want to get rid of the constant term first. That's the term that's not attached to the variable. So in this equation here, the constant term is actually the 7, and it's a positive 7, not a negative 7. So we undo that with subtraction because 7 subtract 7 is 0. Those cancel each other out. And then on the left side, 34 minus 7 is 27. Okay, I could have rewritten this equation as negative 3x plus 7 equals 34. And then it's a little bit easier to see that you need to use your subtraction because of this plus 7 here. Your second step is then to divide by the negative 3, which is the coefficient on the x. Don't forget to bring down the negative sign with that 3. And then when you divide both sides by negative 3, you get x equals negative 9. Okay, moving on to 13, we have x over 2 minus 7 equals 9. So I'm going to undo subtraction first by adding 7 to both sides. That leaves me with x divided by 2 equals positive 16. I then need to undo my division with multiplication, so I'll multiply the left side by 2. That leaves me with just x, and I'll do the same thing on the right side. 16 times 2 is 32. So then I'll check that. So I'm substituting a 32 in the numerator because that's where x was. Divided by 2 minus 7 equals 9. Well, 32 divided by 2 is 16, and 16 minus 7 is 9. So that checks out. Number 14, we have 11 equals x over negative 5 plus 8. I need to subtract 8 from both sides as my first step. 11 minus 8 is 3, so I get 3 equals x over negative 5. I then need to use multiplication to undo this division of by negative 5. So I'm going to multiply both sides by negative 5, and that's going to give me x equals, this is multiplication, negative 15. And so my check for this one is going to be 11 equals, I'll put a negative 15 up there for my x. Negative 15 divided by negative 5 is positive 3, and 3 plus 8 is 11. Okay, I would like you to pause the video now and try 15 and 16 on your own. Remember what we said about fraction coefficients earlier on the front side of your notes. Okay, if you need to look back at those examples, do that. Try 15 and 16, and then once you have answers and have checked, click play to see if you're correct. Okay, so for number 15, your first step should have been to subtract 22 from both sides. When you do that, you get 3/5 x equals 6. And then remember, we get rid of fraction coefficients by multiplying by their reciprocals. So we multiply both sides by 5/3. 6 times 5/3 gives us positive 10. So x equals positive 10 for 15. And again, make sure you've shown your check here. Number 16, we subtract 1 from both sides as our first step. We get negative 1/3. Make sure you bring down that negative sign on the 1/3 equals negative 8. And then the reciprocal of negative 1/3 is negative 3. So we multiply both sides by negative 3. Negative 8 times negative 3 is positive 24, which is our solution to 16. Okay, we have two more examples I want to show you, and these are the exceptions to the rule we talked about with two-step equations. And so this is a what if the numerator has multiple terms. Okay, so if you look at both 17 and 18 here, you see that the numerators of the fractions have two terms, an x and a minus 7 in 17, and an x and a plus 2 in 18. When this is the case, okay, when you have multiple terms in the numerator, you want to multiply first to cancel out the denominator. So equations like 17 and 18, we're actually going to multiply before we add or subtract, and that's going to allow us to get rid of the denominator and get our numerator by itself. So in number 17, my first step, because everything here is over 3, I'm going to multiply the left side by 3 over 1, and then I'm going to do the same thing to the right side. Multiplying will cancel out this 3 on the bottom, and so I'm just left with 1, 1, 1 here, and so all it's going to come down is my x minus 7 in the numerator. So I'm going to get x minus 7 equals negative 12 times 3 is negative 36. From there, I just need to add 7 to isolate x, and so this is going to be x equals negative 29. My check is going to work the same as my others, so I'm going to take a negative 29, I'm going to substitute it in for x up in my numerator. And if you think about your order of operations, we do what's in the numerator first. So that's negative 36 divided by 3, and negative 36 divided by 3 is negative 12. Okay, for 18, same process. I have a x plus 2 all divided by 4, so I need to undo this division by 4 first by multiplying both sides by 4. That gives me 24 equals x plus 2, and then I need to subtract 2 to isolate x, and that gives me x equals positive 22. And so your check would look like this. 6 equals, we're going to have a 22 plus 2 in the numerator. 22 plus 2 is 24, and 24 divided by 4 is 6, so that checks out. Okay, this was a lot of examples, a lot of information, I know, but if you had any questions over it, make sure you've noted that so that you remember to ask those the next time I see you in class. Okay, circle any examples that you were still are unsure why we did what we did, and we'll address those the next time I see you guys. Until then, have a nice day. You're all wonderful people, and take care.